Right, here we go. This is the classic view of the bridge, but don't think about the bridge for a moment. Think of what is either side of it, because what we have is over here, we have the land falling away to Rownham Hill, and over here it falls away to the Avon Gorge, that's upstream, and downstream, it falls away into Nightingale Valley, and it curves around below us in St. Vincent's Rocks. So this point here is the narrowest bit of the gorge. Now the Admiralty, as John said, insisted on 100 feet clearance. Well, we're well in there because we're at 245 feet clearance, so it's more than adequate. We're going to be concerned with the abutment on the far side, 110 feet tall. Think of it as a shelf, and I'll explain what it's doing there. And right from the outset, please bear in mind that we don't know how they built it. We have Brunel's engineering drawings of the bridge and the components, so we can understand and appreciate his engineering prowess and how he thought, how his thinking went. We've got nothing for the vaults. There must have been stuff, but it's been lost. So we know a little bit now, so in the next 15 minutes I'll be able to share that with you. This is a sketch by Hieronymus Grimm, dated 1789. Those little people there are standing where the Clifton Tower sits now. And on the far side there's Nightingale Valley going in, and this wooded outcrop here in the middle distance is where the Lee Woods Tower has gone. So what we've got, I've measured the distance from here to the equivalent level over here on Lee Woods. I measured it on Google Maps, Google Earth, with a little ruler, and it's 900 feet. So that's what one would want to do. One would obviously want to have the two towers of the bridge at the same height, but 900 feet is way a stupendously long length for the time. So now we get to Menai Bridge, and well, you've heard about that. It's 580 feet long, the span, the central span, and Telford had problems with the construction. He said 600 feet is the maximum for a suspension bridge. And because he was so eminent, he was the first president of the Institution of Civil Engineers. When the Bristol Corporation and the Society of Merchant Venturers organised a competition for a bridge at Clifton, they got him along to be the judge. Long story, but he rejected all the entries in a competition. And so the committee were a bit embarrassed, and they said, well, would you like to do one for us, Mr. Telford? So that's what he came up with. He's playing it really safe. You know, he wants to keep his reputation. So what he's got is he's got a 400 feet span, which is nice and safe. But he achieves that with enormous 300 feet high towers. And he's put them in a sort of flowery Gothic style, which was really old fashioned for the time. Us Bristol folk really didn't like it. We thought it looked like two collapsible telescopes. So Telford was, this scheme was rejected along with Telford himself, and two fresh judges were appointed for a second competition. This is what's called the Lancaster Castle design that Brunel came up with. Now, the Bridge Committee were haunted by this statement by the great engineer Telford, saying that 600 feet was the maximum. So what they've done, they've tried to make a bit of a compromise. You can see that the Clifton Bridge sits on quite happily on that natural buttress of rock. It's not quarried rock there, it is down the gorge, but that piece of rock there is a natural formation that's been there for millions of years. So it's fine there. Over this side, what they've done, instead of putting the tower back here, where it should go 900 feet away, they've brought it forward, and it's at 702 feet, 3 inches. And they've done that with a castellated shelf rising up from the wooded slope. The painting by Samuel Jackson, you can see it in the City Museum. This was painted before the bridge was even started. So, but it was an indication of what it was supposed to look like with all the elaborate Egyptian stuff on it. They started work over on the Clifton side in 1831. And after a few months, we had the Bristol riots, and it dented business confidence somewhat. So the whole thing was sort of just put on the back burner. 5 years later, the committee reckoned that the dust had settled and they could now begin to begin again on the construction and on further fundraising, because they didn't have all the money in the pot for it. And they opted to relaunch the project with a grand gesture. Make a start on the big shelf on the far side of the gorge. So make a start on building this. It would be a major construction project which could be watched from Clifton as it progressed. Now, the foundation stone laying was a real big event. This is in 1836, and it's at 7:15 in the morning, because it's high tide, and so lots of people can come along in boats. They reckon 60,000 people turned up. I mean, it's free, and we like free stuff in Bristol, don't we, with the Harbour Festival and the balloons and so on. So there's crowds there. Notice this line coming up here diagonally. If we look at that a little bit more closely, it's a tramway. So what it does, it is built to bring up the rocks, the stone, to build the abutment. So the rocks would come up the river on barges, and then the stone would be hauled up here. This parallel with it, this pathway coming down has flags and so on. That is for the great and the good to come down and make their speeches for the inaugural sort of foundation stone laying when they actually started it. Now, the way this worked was that I can read something from the Bristol Mirror. The masonry for the abutment on the lee wood side is now proceeding with that dispatch as is consistent with sound workmanship. The plan adopted by the contractors for raising all materials to the place of work is well contrived and shows a strict adherence to the economy of labour. An inclined plane constructed of timber follows the acclivity of the rocks, upwards of 300 feet in height, upon which traverses a triangular carriage on iron tramways, worked up and down by a rope, led onto a drum wheel at the bottom. The operation of raising 2 tons of stone or other materials occupies about 5 minutes and is worked easily by 2 horses, the whole of which is prepared and fixed by the spirited firm of Messrs. Ackerman. I'm not sure about that. I thought it was half-ton trucks. 2 tons of rock seems to be an awful lot to drag up the side of the gorge with 2 poor horses. Now, Ackerman was an iron founder. He provided Brunel with iron for the SS Great Western, and he also had this imposing tea warehouse built on Harbourside. It's the Bush Warehouse, now the Arnafini. He did actually sponsor the Bristol School of Artists, and they painted these sort of atmospheric scenes in Lee Woods in the 1830s. So it's a nice touch that he was hired to work on the Lee Woods part of the bridge. Let me introduce you now to Wendy Shepherd and Pat Howe. Their maiden name was Ackerman. They are the great-great-granddaughters. Now, Ackerman's little tramway, from where they're standing, transported all the stone for the abutment up the side of the gorge. It had arrived in barges on high tide. And then it did the same for 4,000 tons of stone for the tower itself. So we can see on this next one, we can see the relative position of the 2 towers. This is an accurate scale drawing. So the chains, they hold up the deck. They're simply resting on the tower as they pass over saddles, and then they go deep down into the ground where they're anchored. What we're witnessing basically is a tug of war that's been going on for 156 years. And the Lee Woods Tower, the left-hand one, should really be set back to about where the chains go underground. Now, this is the only, the earliest representation we have showing the construction. The nearest tower is Clifton, which is being built as 4 separate pinnacles, which then get infilled at the sides. In 2002, the bridge trustees decided to replace the tarmacked paths beside the approach roads and around the towers with pennant stone paving. When preparing the ground, the builders discovered a vault running across here. So that's between the tower and the parapet. There's the vault. Now, you saw the stepped up foundations. There they are there. So we're looking at sort of parallel with the portway with the river. This is adult height, but you wouldn't want to stand up in it because you'd hurt yourself on the stalagmites. So Ray, the paving contractor, was amazed at this discovery. Everyone was really excited by this. And Ray thought, well, if they've got a vault here for this little titchy abutment, there must be vaults on the other side. Now, as I've said, there's no drawings or specification existing for the way they built the vaults. But the abutments and this big face here, the rock buttress, have been tested regularly. They're not moving, they're safe. In 1969, Bristol University's engineering department drilled into the vaults wall here and extracted cores of stone. And that made them think that the vaults were solid. They didn't hit any voids. If we look a bit closer at this elevation, we can see where the tower could be located really, and that's way back here, where just around where the toll houses are. That's where it should have gone, and in fact probably could have gone. And one could say that Telford was a bit timid with his sort of 600 maximum feet pronouncement, but bearing in mind, there wasn't much empirical evidence about that. John said earlier that the predecessor of the Menai Bridge was a really titchy little bridge. So, what do you do? I mean, it's like the second Severn crossing now looks nothing like the first crossing, does it? And there's only about 40 or 50 years between the two of them. So one learns from looking at stuff and thinking, oh, I won't do it like that. But while we're here, this might interest you. It says there 348 feet is the height from the water of the top of the tower. And that one says 351 feet. And then we get to, there's Ray, excuse me, looking very pleased with himself. His hunch was right. The leeward side is not solid. It's a network of a dozen barrel vaulted chambers. And it was a discovery of his shaft that has proved that. This is John. He was the first person to descend into the belly of the beast. He's all carabinered up, ready to go. On tours, it's quite enthralling to stand on the metal manhole there, which covers the shaft. Here's his description. I was lowered down, and at 20 feet, I could see tunnels going out horizontally either side of the shaft. Then another 40 feet. And there were another set of tunnels either side of me, exactly the same thing. They had stalactites, or the calcite deposit from the lime mortar, that had dripped down through the stonework. We reached a chamber 30 or 40 feet high and wide. John descended that shaft there, went into this chamber, and then wriggled around these. These are all 2 feet in diameter, all these shafts, so it's a bit like potholing, really. And then he came down this narrow shaft here, which is about 10 or 11 feet long, into this enormous chamber. We don't know, he saw it, he was the first person since 1840 to see it in all its soaring glory. We don't know what he said. We think it was golly. Okay, we'll assume that. So that's all for now. Thank you.